Let's move on to the next question. The first term of an arithmetic progression is A and the common difference is D. Okay. Now at least we know the type of progression that we have to work with. That's the first good thing. Now once we know that, let's write down the formulas we know for that kind of progression. So the n term is given to you by A plus D n minus 1. Sum of the first n term is given to you by half times n 2a plus n minus 1 times d. Okay, so these are the two equations usually we should know for the AP progressions. Now part 1, we have to write expressions in the form of a and d for the 5th term and the 15th term of this progression. So one by one, pretty easy. Replace back in your formula here. Let's see what do we have. So 5th term is what? When the value of n is 5, you will have a plus d. 5 minus 1 is 4. So you have a plus 4d equal to the 5th term. Right. Now what else do we need to know? The 15th term, so 15th term, same steps. A plus d. 15 minus 1 is simply 14. Have to be a plus 14d. Okay, so 5th term and 15th term given to you by those two expressions. Okay, pretty easy till now. Now the first term, the 5th term and the 15th term, so the first term, the 5th term, and the 15th term, which is this one, are the first three terms of a geometric progression. Okay, so now these three are the first three terms of a GP. Great to know. Now GP, let me first write down all the formulas we know for GP. So we know the n term is given to you by a r n minus 1. Then we know the sum to infinity given to you by a over 1 minus r. And the first term is obviously just a. That is for GP. Again, this is given to you as well in your list, so you don't need to worry about those. But it's always best to kind of write this down for now, and then you can use that directly to find your following values or the answers. So we have to use this information to show that 3a is equal to AD. So how can we use that information? This is my first term, second term, and third term. So we have to show 3a equal to AD, and then we have to find the common ratio, that is the value of r, in this progression. So let's think of this one by one, and let's try to find the following values. Okay, so now we understand what? We understand that. So for example, from this term to get to the second term, if it is a GP, we have to multiply by r. Same thing here, multiply by r, right? So let me write this down. We know that from the first term, if you multiply by r, you will get the second term. And from the second term, if you multiply by r, you will get the third term. So here we can use that information or equation to solve or to show that we have 3a equal to AD. First thing first, let's make r become subject. That will be this divided by a, and r will be this divided by a plus 40. Now obviously we can solve a simultaneous equation because r is obviously equal to r. So on the left hand side you will have a plus 40 over a is equal to a plus 14d over the value of a plus 40. Now we can simply cross multiply. You will have what? On one side you will have a plus 40 square, and that will give you a square plus 1480. So now we just have to simplify. That will be a square plus 8ad plus 16d square is equal to a square plus 1480. Now these two will obviously cancel out. So finally, we have to send this over here. You will have 16 a square, so d square is equal to 680. Obviously, cancel d, that will be 16d will be 6a. Divide by 2, you will have ad will be 3a, which is the same thing as saying 3a is equal to 80. This is shown as required. So now we have to use this value to find the value of R. So let's replace back in this equation. Now here we have 8D, but here we have 40. How can you make 8 become 4 divided by 2? You will have 40 here, and that will be 1.5a, right? So replace this by this in this equation. So R is equal to a. 40 is 1.5a divided by the value of a. That will be 2.5a divided by a, and that should be 2.5. Okay, so your common ratio is equal to Rn, which is simply 2.5 for your answer. Okay, and this is the question number 3 for this GP question.